So today we will draw the first case now when object is placed at infinity. If you remember, we have done this case in time of mirror also. But before we start with the ray diagram, I am going to teach you that how we draw the lens with the help of the pencil and compass, and we will require scale also. So this is the first way by which you can draw. Here you will need to draw the principal axis first. So with the help of the scale and pencil, the first and foremost thing you need to do is draw the principal axis. And after that you need to draw the aperture. Now this is your choice, whatever length you decide for your aperture, but it should be equal above the principal axis and below the principal axis. Suppose if it is 2 centimeter above the principal axis, then below the principal axis also it should be 2 centimeter. Now with the help of the compass, I am going to measure my radius of curvature, that is the center of curvature. So I am taking it as 4. This radius of curvature, I am taking it as a 4 centimeter because half of it will be 2 centimeter, and this is a good length for measuring the rest of the points. But if you want, you can take it 3 or 5 or whatever centimeter you want. Now from the point, this particular point, we have done this part already, the terms associated with spherical mirror. This part is known as O, which is known as what? Optical center. Now from here we will mark a point on the principal axis, that is on right hand side, and also on the left hand side. So this becomes what? The center of curvature, that is C1 and C2. Now when the center of curvatures are already marked, we will point the compass here, and we need to stretch the compass so that it reach the 2-point end of the line. The line which you have drawn for the aperture, it should meet the 2 end points of this line. Now when this happens, at that time you need to draw the curve that will be crossing the 2 endpoints of this aperture line. The same you need to do with center of curvature 2. See, and this is how the convex lens will be formed. So this intersection part, which is the leftover portion, you can erase it later on, or else you can leave it like this also, it does not matter anymore. Now the rest part will be, you need to measure the focal length. So since it was 4 centimeter, the half of it will become 2, and since the lens have the focal length and the center of curvature on either side, so we have 2 focal length, 2 principal focus, and 2 center of curvature. I have drawn it with a pencil, and this is what you have to do it in your notebook also. Children, I will show you another way of making convex lens. This was done by the compass and the pencil, but now I will show you that this lens can be drawn with the help of protector and a scale also, and a pencil also. What you need to do, the first part is remain the same. You will first draw the principal axis, and then you will draw the length of the line for the aperture. And then with the help of the compass, you have to keep the compass, that is the 90 degree part, that is the center line, will coincide with the principal axis. And you have to keep it in such a way that both side of the aperture line that makes a curve with the protector on the either side, like this. And so this is an easier way of making, faster way of making the convex lens. You can use this way also, or if you want, you can use it with the help of the compass and scale also. Now for the center of curvature, since we haven't used compass here, now for the center of curvature you can use any particular length of line. Like here I am keeping the 0 centimeter at optical center, and then marking 4 centimeter as my center of curvature. The same can be done for the center of curvature on the left hand side, that is the 4 centimeter, like this. So these two points are marked as center of curvature, C1 and C2, and the middle of them, midpoint of it, will be marked as the principal focus. So with this we learn that how we will draw with the help of scale and pencil the convex lens. So this is the first case, children, and here the rays are taken parallel to the principal axis. You can see why it is taken parallel, because it is coming from infinity. So we do not place the object on the principal axis. We have done this earlier. And since this is a converging lens, so the rays after passing from the optical center, see this part you have to make the parallel ray till the line of the aperture. That means the line of the aperture, the parallel rays will continue, and from there you will show the bending. Okay, not from the rim, but from the aperture line. So from here the ray will bend, and where it is going to meet? Toward the principal focus. So with this we can write what is the position of the image at F. The size is point size or highly diminished, and the nature is real and inverted. So this particular diagram can also be used to draw the same thing that we have learned. So with this we finish the case 1, and now in the next video we will see the case 2 and case 3.